Faculty of Computing at SLIIT has mainly focused on the research topics of cognitive computing, software engineering, e-learning, and many more. Notably, her fascinating doctorate research covers the topic of a cognitive complexity metric of software. Undoubtedly, she is one of the perfect speakers to handle the topic today, so without further delay, we hand over the session to you, Doctor.
Okay, I will share my screen. Varsha, can you see the screen? Apologies if you have kind of a video delay. In my case, our area is heavily raining now. So in case if I have a network problem, I am going to apologize it first, right? Okay, so hello everyone, and I'm Dinuka Wijendra. I'm working as a senior lecturer attached with the Department of IT, Faculty of Computing, SLIIT in Malabé as the main campus. So as today's session, I'm going to just talk about the applicability of the cognitive complexity in the domain of software engineering. So first of all, I'm going to talk about what do you mean by the cognitive complexity. I think if you have been dealing with some software industry, or if you have been discussed about some software complexity matrices, you may have learned or you may have heard this cognitive complexity concept. But if someone is kind of if someone is not knowing the concept of cognitive complexity, anyway, I will start from the beginning. Okay. So before going to the cognitive complexity, I will just let you know how this cognitive complexity is coming to the software point of view. So we know that as the software developers, what we are going to always develop is software. So software is kind of a code base, or if we have a customer and if the customer is pointing out with a kind of a problem, how to address that problem or set of problems is we are going to develop a code base. So when we are going to develop a code base, it should address what the customer says, as well as it should be a qualified, as well as it should have a less complexity. That's why we have like hundreds, like many complexity matrices. And apart from that one, if you just think about the word called complexity, complexity means if a source code or kind of a software is given, how to understand that one, the understandability. So understandability is kind of a very significant or prominent factor when it comes to the software complexity point of view. So if we have been given a source code, so there has to be a source code to understand, as well as there has to be a human developer. So developer is probably the human being. So with the human being factor, the personal skills and the experience has to be concatenated with each other to cope up the understandability of a given code base. So from that one, if we have just think about the understandability plus the code source base given, we can just prompt out what do you mean by the cognitive complexity is. Cognitive complexity means when a source code is given, up to what extent a person can understand the source code. I mean, not the source code, actually the logic behind that. So the source code is having a logic. By executing that logic, by converting into a programming language, we are going to produce the output. So why we want to understand this one? Someone might be thinking, so I'm going to developing the source code as a software developer. So if it is producing the output, why someone could understand that one? Because we know that time to time the software is changing, or time to time the customer requirements can be changed. So accordingly, we have to modify the source code. We can't say that we can have a software without a maintenance. So we know that under the software development lifecycle, the maintenance, under the software development processing, the maintenance is having kind of a very significant, it is kind of a very significant process. So You might be developing a source code. The same source code, another person might be modifying. So in order to modify, prior to that, he or she needs to understand what is under that. Otherwise, how he or she can continue the maintenance or continue the modifying. So that's where the cognitive complexity is going to be useful. Because if I can't understand what you have written, I can't do the modification. So there's a problem there, even though you can have the output. So person to person, we know that now cognitive complexity is affecting with a personal factor, because we all are developers, or we all are kind of a person, and from person to person, the way that we can understand a source code is different. So if I give you a source code among all of you, I can't say that all of you are going to understand the concept in the same way. So that is why we call it as the understandability. It's a subjective factor. What do you mean by a subjective factor? It is going to different from one person to another person. Like, it's not objective. So objective means it's all for all the persons. It's not going to change. But subjective means from one person to another person is going to be a different. So why is that? Because the understandability or the comprehensibility of each human is different from each point of view. So that you might be thinking, so if the cognitive complexity is a subjective measurement, how we can measure it? Because as a complexity metric, now if you go for a metric is producing an output like a number, like a quantifiable number. So if you think about LOC, and if you have been given with a code, for all of us, the LOC value has to be same for one program. But if I think, if I give you the same source code for all of you, and if I ask you what is the cognitive complexity, you can't say it as a quantifiable number, because the way that you are going to understand is different from another person. So then how we are going to measure it? So that is the big question we have. So it is what we are it's the dynamic indicator. So it's dynamic indicator means from time to time, it is going to change. So based on the timing factor or based on the complexity factor, it is going to change. So keep in mind always, if you are going to talk about cognitive complexity, it is a subjective measurement, as well as it is very difficult to model, because from one person to another person, it is very, like a metric, it is going to be changed. So actually the main question is, as a metric or as in a computational model, how we are going to model this one. So if you are working with research as with the software complexity matrices, you can see there are so many researchers going through this concept called cognitive complexity. Why? Because of this subjectiveness aspect, it is very difficult to quantify as an objective measurement. So that's why lots of researchers are going to be conducted from this point. And I will tell you what is the importance and some of the aspect I have already highlighted. So cognitive complexity, simply we can say the comprehensibility or the understandability. It is always helping to the maintainability process. So whenever we are going to develop a source code, it's like a teamwork. Lots of persons are going to be there with that software development process. So one set of people are going with the coding. Another set of people are going with the designing part, another set of people are going with the maintenance and the testing processes, something like that. So when it comes to the maintenance, you know that it has to be understood. The logic of the source code has to be understood, so that if we have a proper cognitive complexity concept or proper cognitive complexity metric, we can just quantify the comprehensibility level of each and every person. And if those each and every person's comprehensibility is in a acceptable level, only we can give the chance for them to understand it and modify. Otherwise, if the skill level or the experience level of a person is too low, we know that definitely he or she can't understand the source code. So if he or she can't understand the code, the source code, no point of giving the source code to the maintenance. So it's simply something like that. So if you have this kind of a concept, and if you can quantify it, or if you can verbally express it in some standard way, we can directly get only the suitable persons to do the main thing. That's what I want to just say as one of the significance of the cognitive complexity. And the other one is, as I told you, if we have this kind of a standard cognitive complexity metric or kind of a framework, it is very easy to do the software project management. Because I told you, one software is not going to develop by a one isolated person. It's like a teamwork. Different capabilities of different team members are there inside one team. So how to categorize one, like a unique set of subgroups? Simply, we can use the cognitive complexity metric or cognitive complexity kind of a framework. So if we have same set of, like, if we have set of people who is having like same set of understandability, we can have it inside one group. Then no conflicts are going to be there. So that we can facilitate more contribution, collaboration among them. So that the group work and the teamwork is going to be like done in a very smooth way. So like that, we can have the cognitive complexity metric or the framework in a we can use it like that when it comes to the software development process. And I just have to thought of like discussing the past researches which have been done with the cognitive complexity. So I just mainly divided in like this. So some of them have expressed the cognitive complexity as a metric. As you can see inside the left side panel, you can see they have expressed it as a metric. Some, I mean, when it comes to the metric, you know that that has to be a quantifiable value. So when it comes to the quantifiable value, you know that you might be thinking how the subjectiveness can be quantifiable. So there we can clearly see that this is kind of a major drawback in the past cognitive complexity matrix. What is that? They just completely remove the person factor, because of the person factor, the subjective is coming. So that they just completely remove the person factor and just think about only the source code factor to determine the understandability. So we can see that there's a huge gap there. So that none of the cognitive complexity metrics which have been declared before, we can't say it as a standard one, because the person factor, the human factor is lacking here. On the other way around, you can see in the right hand side, cognitive complexity has been expressed with the qualitative way. With the qualitative way means they knew that it cannot be expressed like a quantitative value, or we can't just remove the personal factor in the sense it's subjective. So that they just qualitatively like express the software attributes using cognitive complexity, as well as cognitive complexity has been used to express the software quality attributes, like vice versa. From the quality attributes, they have explained the cognitive complexity, as well as cognitive complexity has been used to express the software quality attributes. Like that, mainly we can divide these things into quantitative expressions as well as qualitative expressions. So, if we think about quantitative expressions, I told you they have mainly taught about only the source code factor. There you have, you can see there are two boxes. Architectural aspect means they have mainly thought about the amount of information inside the source code. So amount of information inside the source code, they have categorized into something like this. You can see with the bullet points like variables, how many input or output parameters are there, how many operators and operands like in the Halstead software metric, methods, what are the object-oriented concepts, and BCS means what are the basic control structures and nested basic control structures. Like that, we know that if we have a source code, there are many different kind of data. So this kind of data, they have quantified it, and they have came up with different equations to say this is the cognitive complexity. Plus, in the right hand side, you can see another aspect called spatial aspect. Spatial aspect means the size. Or from now, if we think about a method, there has to be a method call and there has to be a method implementation. From method call to method implementation, how much that the user has to bypass. Then we scroll down. So now when we are thinking about the logic, we can't say the code is flowing like a sequential way. There are so many ups and downs like that. The jumping is like when it has like callings, there are so many jumpings. We can't say that it's like the compiler is compiling everything in a sequential order. So in that sense, they have thought about the spatial aspect as well. Together with these two, they have expressed the cognitive complexity like in a different uh, equations. As well as you can see in the latter part, they have expressed something called cognitive weights. From the cognitive weights, they have tried to contribute with the personal factor, but again, there are so many disadvantages, so there are so many drawbacks like that. So then we will think about what do you mean by these cognitive weights. So cognitive weight means it is like a numerical value like 1, 2, 3, 4. What they have done is they have thought about some kind of like basic control structures or variables, something like that, and they have taken a test, kind of a group test users. It's not demonstrate the entire user, like 50 or 100 test user group, and they have analyzed how they are going to identify like either the basic control structure or either the variables or operators or operands, something like that. They have just investigated or explored how they have understood these concepts, and based on those understandability levels, they have expressed, if it is like basic control structures, for the if condition, the cognitive weight is 1, because that's the very easiest one for that users. And for the switch case, we know that if else and switch case, that's the same thing. So as I think you also prefer to use if else rather than using switch case. So that in that sense, they thought that is the easiest one. So that they have mentioned it like 1. So if it is the for loop and the while loop, I might use the for loop where you might use the while loop. Like that, if they have just quantified the comprehension level or the preference into some small values like 1, 2, 3, 4. But the huge disadvantage, these are the values, the categories that they have used to express the cognitive weights. And they have basically used assumptions. What kind of assumptions are there? Now, when it comes to the program to program, the basic control structure, the capacity of that one, or the capacity of the variables, constant data are going to be different. And if the group is having 50 users, whatever the values that they are getting, they are thinking it is applicable for the entire users. So we know that if 50 people like users answer cannot be applicable for the entire generic users. For an example, you might know like while loop very much, but I can do the same coding using the for loop. So you and me, the preference or the understandability level for that controlling is different. So how you can say whether your preference and my preference or your expertise level and my expertise level is same? So that kind of a very different, difficult ideas we can't combine with these cognitive weights based on these assumptions. So then we can see or we can finalize or conclude this cognitive concept is not, cognitive weight concept is not working as it is. So these are the drawbacks that I have told you. So the factors, now one research, if you think about one previous research, they had thought about like basic control structures for the cognitive weight determination. And another research, they thought of like operators and operands. It means from research point to research point that this cognitive weight quantification is different for each source code factor. So it's not generalized. And the other one is, as I have told you, they have used limited number of users. And they have used so many invalid assumptions to quantify those things, so that we can't say this can be applicable as a standard metric. So from that point of view, we will stop the quantitative expressions of the cognitive complexity, and we will jump for the qualitative. So qualitative means like as a description, we are going to express it. Then these are the things that they have used. how the cognitive complexity is mapping to the aptitude level or expertise level of the coding, and how the cognitive complexity is mapping with the defects ratio inside the source code. How exactly the cognitive complexity is directing with the understandability or the comprehensibility level of a user. And if the cognitive complexity is there, or if we can express the cognitive complexity, how you can determine what are the tasks which is very time consuming and complex, and how to identify successful projects in with the concept of cognitive complexity. For an example, cognitive complexity means the user understandability level. If the user understandability is very high, or if the effort that I need to put to understand a source code is very low, it means understandability is high. Simply, we can say that effort to understand something. So if I need to have less effort, it means it's easy for me. So that's what the successful means. If we can do something with a very complex way, anyone don't want something like that. We always like to go in a very slightly smooth way, so that the effort will be reduced. But I always remember that if you think about cognitive complexity with the software, that has to be very less. Okay, so you have to think about the cognitive complexity in a way that it should be very less, so that we can think the understandability is very high. So this cognitive complexity has been used in other domains as well. So I just thought of listing down these things as well. So when it comes to the business process modeling using UML diagrams, and with the simulations like aircraft collision, and when it comes to the gaming designing, career development, theater-based applications, this I can't say this is only the other domains. So I just listed only some part. But don't think that cognitive complexity can be applicable only for the software, like in a software engineering. Cognitive complexity means user understandability. So user understandability is crucial for any kind of a domain, because if you can't understand anything, no point of dealing with that. So it is not limiting only to a software development. So like this concept has been used in many other domains. So it is not limited for that. So I thought of after that, these are some investigations or explorations which have been done to express the cognitive complexity in a quantifiable and qualitative ways. So then I thought of just listing you what I have done inside my PhD, but I'm not listing everything because you might not be understanding some points. So, but I just thought to let you know some of the details, so that if you are interested in doing higher studies, or if you want to collaborate with us, because most of the SLIIT students also collaborating with me with their undergraduate projects. So I have divided because with a PhD study we can't do everything. Still some parts are remaining. So I have just scoped down some parts, and I have given those things as their research, like BSc projects, so that I thought of just explaining what I have done in a very abstract way, so that you can identify some of the research parts which has to be continued, because I didn't do everything. So these are the research gaps that I have that I found in my PhD theory, in my PhD work. So if you can remember what I have done, explained in the literature review, I thought the personal fact is totally removed, so that we can standardize the cognitive complexity either in a metric way or either in a the computational way. So they have used only the source code factor, but what I thought was it should be the source code factor plus it should be mainly go for the personal aspect as well. So the personal factor has to be however introduced or however included, because under the cognitive complexity, it is asking to say what is the comprehension effort of a user. So if it is talking about a user, how we can ignore the personal profile? That's the main research gap that I have found. And the other thing is, even though some of the connections are there, how this cognitive complexity can be applicable for the software development process has not been discussed in anywhere. So the cognitive complexity is the user understandability or the comprehension effort. And how we can apply these things under the maintainability or the designing or the coding levels has not been explained. So that has to be explained. Otherwise, how we can model a software with a lesser comprehension effort, we don't know. So those are the some of the research gaps that I have found. So from that, I have developed my research problem, how this cognitive complexity can be applied in an effective way to enhance the development process and the maintenance process when it comes to software. So this is my research problem, which I have divided into 3 research questions like this. So based on these 3 research questions, I have developed my computational framework and the metric. First of all, I want to know, if I just want to mention about cognitive complexity, what are the main factors and the sub-factors? And I told you the cognitive complexity for whatever the software has to be lesser, so that the comprehension effort is lesser means the understandability is very big, very high. So how to do that? What are the procedures that I have to follow? And then you know that this is a complexity. So complexity by using a qualitative expression is not enough. So anyone can say any expression. So how this subjective thing can be quantified? So that is the biggest problem that we have. So the from person to person, how the metric can be changed. So that is the biggest research question that I have to address. So let's see how we have done that. So under that research, 3 research questions, I have developed these 5 research objectives. So under the research objective 1, I have identified the factors which is affecting for the cognitive complexity as well as sub-factors. And under the research objective 2, I have identified inside the software development process how to reduce this cognitive complexity. And that reduction methodologies I have designed inside a computational framework as the output of research objective 3. Then the designing part of the cognitive complexity reduction is over. Then under the research objective 4, what I have done was how to propose a subjective cognitive complexity metric, not an objective, because we know that comprehension effort is subjective. So definitely through a metric, it has to be a subjective measurement. And under the last research objective, what I have done was the computational framework plus the metric I had evaluated through the standard complexity frameworks. These are my novelties. So every cognitive complexity research has been gone through only the source code factor, but I have concatenated the personal profile factors as well. And how this cognitive complexity can be reduced under the software development and maintenance process, I have, through a computational design, I have shown. So this is my methodology. So I thought that to listing it down with the all the research objectives. So this is how I have identified the research objective 1, which is identifying the factors. So as you can understand, I told you there are 2 main factors which is affecting for the cognitive complexity. There has to be a source code to understand, and there has to be a person who has to understand the logic. So mainly the main 2 factors for the cognitive complexity is personal profile as well as source code factor. So from that, the personal profile I have highlighted, like I have under the personal profile, the sub factors I have mentioned it like this. So in a person, in order to understand something, the person has to have some memory. That is the main thing. Because if we don't have a memory, or if we don't have a capacity to understand something, so that capacity means the memory, what is processing in our human brain. So if we don't have that capacity, we don't know what to do. So if we don't know what to do, we don't know what to understand. So the very first sub-factor that I thought was the capacity. So if we think about the capacity of the memory, as you know, or if we don't know, anyway, the memory, we can divide it into 3 sections, like long-term, short-term, and working memory. So in my research, I have just thought about the working memory because of the scope of the research work. Okay, so it does not mean that the long term and the short term is not affecting for this. Actually, it's affecting, but for a given time, for given person, how he or she is understanding is working with that working memory, because at that particular time, I'm going to think of. Okay, so with that particular time, how I'm going to collaborate with my memory and how I'm going to use it. Now, for a simple example, if you have been given with a question paper, a question when it comes to an exam, you might be not doing that. But if it is not an exam, the same question, you might be able to do that. So then the capacities or the understandability levels for the same question with two different scenarios are different. So for a given time unit period, how you are going to identify the source code. That is what we call it as working memory at that time. So working memory also, there are three sections, because for the working memory, we call it as under the working memory, how much information that is coming or that is processing inside your human brain. We are calling that one as cognitive loads. So that cognitive load under the working memory can be divided into these three sections. That is, we call it as intrinsic, extraneous, and germane. Intrinsic cognitive load means with a source code, how much exact or how much correct information which is flowing into your brain. Extraneous means with the source code, what are the unnecessary memories that you are dealing with. And germane means how much deep cognitive load which you need to understand the source code logic. Okay? You might not know in that one because it's too, for your level, I guess it's too deep. But from the abstract, like if you just think about from the overview, that is just I was thought about how much working memory is applicable. And along with that, the processing of the memory is not enough. You want to have kind of an aptitude level, like you want to have some knowledge of the programming. And you want to have some practices, experience. And age is also for some point, up to a certain extent, I thought, because you know that from when you are going to be age up, like when you are like growing and growing, we know that when it comes to 50 and 60, even though we are capable, I mean, like we are not capable like 40s and 50s, if it is like 60s and 70s. It means from age to age, even though the experience can be grown, the knowledge level or the capacity level, actually, capacity level can be go down. It's something like that. And the source code, that is a personal factor. And I told you the other factor is the source code. So again, I have taken the same architectural aspect as it is, because if we don't have set of information inside the source code, we don't know what to understand there. So the amount of information we have to think, and the spatial capacity, as in the literature review, I have taken as it is, because the size and the distance that I have to bypass from method call to method implementation or variable usage to variable definition, it actually matters for the comprehension level. So these two I have taken it as it is from the literature review. And plus, this is the third one is the thing that I have input, the programming environment. Doesn't matter how much information and the spatial capacity is adhering to the source code, the programming environment, the supporting IDE or the supporting functionalities, libraries, the availability of the comments, those things, if you have some supporting factors, it's good to identify what are the things which is there inside the source code. Though the supporting functions under the programming environment also I have considered as subparameters, which is coming under the source code factor. So from that, the research outcome one, research objective 1 is over. So then under the research objective 2, with these things, how to reduce the complexity to get a lesser effort to understand something. So there I have, this is the scope that I have done, one of the scope down. For this, my research, I always assume that the user has been given with a source code with correct logic. Because if you have an incorrect logic, no point of understand that one. Because sometimes we might be getting something like that. So no point of utilizing our effort for that. Because we know that if it is an incorrect logic, we don't get what we want at the end. So no point of doing something like that. So in my research, I always target the user is having always the correct source code with him or her. Then, and in order to reduce the cognitive complexity, I thought that I have to handle the inconsistencies with both of the personal and the source code factors. So this is what I told you. In my research, I have mainly concentrated on the working memory, which is like intrinsic, extraneous, and German. So this is how I have done that one. My main target is to reduce the cognitive complexity. And under that intrinsic, German, and extraneous, I told you extraneous is the unnecessary one. So unnecessary working load, I have to reduce it. Now, what is mean by unnecessary working loads? So unnecessary working load means if the source code is given, if you want to check whether it is correct or error free, that is not going with the logic. So first of all, some of the effort has to be given for the correctness. So that is, we are calling it as extraneous. And if it is not a structured one, now think that you have been given a source code which is typed in a notepad. So it's not a structure. No, we don't know what are the indentations. It is not implemented in IDE. Like if it is like IDE, you are having so many different colors for a variable, and even it's wrong, you know that the wrong part is going to be highlighted with red color. Nothing is there if it is like a notepad thing. So how to make it a structured code? It is not going with the logic. So these things are unnecessary things. So that is, we have to reduce. So that while we maintain that one, we have to do the implementation of the other necessary cognitive loads, which we call it as the real cognitive loads that we have to maintain is intrinsic and German. So there what you do is, if we don't have the necessary information by assisting these things or implementing these things, we can have some extra mechanisms to identify that. So under the first one, I have taught you like visualization. Visualization means, now when we teach students also, we do something like that. If we have a very hard concept, while we saying that one, we try to visualize it on the board. So by using some sketches. So we always know that picture is always a very easy way, or visualization is very easier way to understand something. And the simulation, if we can simulate what exactly we are going to say, that is another way. And if we have some guidelines or recommendations to understand these things or to make this process in a very better way, still again we can see that will actually help to understand our source code. So these are some of the points that I have taught. And then I'm coming to the research objective 3, which is the designing part. So I'm not going to explain these things too much, because this is, I don't think that this is for your, this can be okay for your level. But this is what I have done. This is my total framework. You can see in the left side panel, I have determined what are the process that I should follow to increase my intrinsic and German cognitive loads for a user. Otherwise, in the right hand side panel, you can see that how I have deducted the extraneous cognitive load so that the total effort is going to be in a balanced way. So for that one, I have used a proper requirement analysis process. I have computationally processed that one. And under the next one, I have done a visualization. I have given a visualization for a user before the source code, as well as after the source code implementation. So I will quickly go through this one and let you know how I have done that one. And under the right hand side panel, under the reduction of the extraneous cognitive load, I have implemented how to track defects. Now there are so many defect trackers, but in my case, I have addressed some defects which is not addressed by the existing defect trackers, and how to optimize the code qualities, and how to introduce the refactoring. So you might be thinking these things are already developed, but what I actually in IDE is, so most of the IDE is this defect tracing, the quality optimization up to the certain extent, and the refactoring option is already implemented. But I have concatenated which some of the most significant these techniques into a one component, and I have implemented into a computational. So this is what I have done in the requirements analyzer. We have inputted the project proposal, and inside the project proposal, I read the project, not the computer. In the back end of the computer, it is reading the project proposal and it is identify the functionalities which has to be implemented, and then output only the possible class names which has to be inside the source codes. Because from just by reading the project proposal, the computer cannot identify or build up the codes, because that is still done by a human. So we can't just have something like that. So as the process, the initial process, I have identified only the possible class names or possible things which has to be appeared inside the source code. And then under the visualization, before the visualization, I gave an idea to the user. This kind of a logic has to be there inside the source code. So this is what I have done. So from the very earlier one, I have generated the class, and the classes, I have analyzed the relationship between cosine similarities. And with these things and the other logic which is mentioned through the project proposal, using the plant UML theories, I have design these three class ER object diagrams. This is the main significant thing in my case, because this is going to be designed before the source code. And after the source code also, I have done like this, so that you can I had an opportunity to compare the before visualization with the after visualization. And then the defect tracing was like this. So I have used actually NetBeans and Eclipse both for my, because I have done the project using Java, and the Python based part is also there. So there I have used the Find Bugs Bug Tracker. I don't know whether you know that. So I have installed that one as a plugin, and Find Bugs is not tracking all the defects of the source code. So though, which is not tracking those trace those defects, I have with my component, I was able to identify the defects which is not identified find bugs. So with that, I have prepared an error log, recommendation, summary, and everything, so that it is very easy to user to go with the recommendations and with the error log to recorrect the errors if any. And the code quality optimizer also something like this. So with the Java static code analysis, I have identified some quality issues. So we simply say that code smells. Code smells are not going to be identified by some of the IDEs. So I found some of that, and I have implemented my component in a way that it is going to be identified itself and automatically fix it. And in case if the user wants, user is guided with some of the recommendations. So within one shot, by reading that recommendation, user is able to do the quality optimizing. And refactoring suggest is also, I have done it like I have done it using JavaScript file, like client server based thing. So if in case if we have a refactoring, or because refactoring and the code quality is like one-to-one mapping is there, because if we have some quality issues, it is very hard to understand what is inside that. So make sure that we have applied the refactoring techniques, and then and only we can start the understanding. So that I have done it like this, and through the HTTP request, I have done the refactoring to the I have implemented refactoring suggested. So those are the things that I have implemented to say what are the computational mechanisms that I should follow to reduce the cognitive complexity for a particular software. And this is the most crucial part, how I have ended up with a cognitive complexity metric, so which is subjective. So these are the things that I have done. Simply, it should go with the personal profile as well as source code factor. And I also use the cognitive weight, but not with the assumption or not with a set of user as in the literature. So for the source code factor, as I told you, as the sub-factors, I have used architectural aspect as well as spatial aspect. And under the architectural aspect, variables and basic control structures I have used. I will show you the equations that I have got through. And from the variables and attributes, I have defined something called data complexity. From the basic control structures, I have defined another part for basic control structure. And this is how I have identified my cognitive weight. Not my, I mean, how I have introduced the cognitive weight concept without limiting to any kind of an assumption. So if you are a user, you have been given some factors to validate by yourself. So from the back end of the computer, with the data that you are going to supply or input for that particular programming program is going to be trained using like Gaussian bias and linear regression. Linear regression I have used for the quantifiable value. This qualitative expression I just used only Gaussian naive bias. So actually for the metric computation, we don't want any qualitative aspect. I just use it for both validation, but for the metric, you have to use only the quantitative expression. So from that, for each and every person, different cognitive values or cognitive weights are going to be generated. So it's for you. That cognitive weight is not applicable for another person. So that's how I have done it. So you can't say that I have used any assumptions, because this cognitive weight has been generated based on the factors that you input to my model. So that is up to you. So for the same program, if someone has logged, someone has input or validate, that cognitive weight is another one. So from person to person, you know that this CW value is different. It means subjective. Subjective plus it's a quantitative value. Then this is, I'm not going to explain these things. It is going with the frameworks and the equations like that. So actually this is, you can see CW is the subjective cognitive aspect for each person. From person to person, that quantifiable value is different. So actually this is what I have done. This is my cognitive complexity metric. Okay, like this. And the next one, I have introduced, I can't say this is a research work, this part only a research work. Here what I have just want to say is, we have different cognitive complexity, different complexity matrices, like LOC, CC means cyclomatic complexity, Halstead operators and operands, like that. So whenever the Java source code has been inputted to my model, I have given the user the option to calculate the complexity from those standard complexities as well. Plus, from my model, the cognitive complexity is also going to be calculated. So those things, how we can relate those things. That is what the ultimate goal of that one. Nothing new here. I just want to express, if we just limit for the software complexity, how software complexity, it's like an objective. So as I told you, LOC value for one program for whatever the user is same. But if we jump to the cognitive complexity, it's not same. It's different because of that CW value, which is going to validate by yourself. So that's kind of a relationship mapping. I thought that anyone can understand from this section. Rather than that, there's no research under this part only. Okay. And you might be thinking, so I have used this kind of CWs and data models, and I have used some different mathematical computations, small ones and big ones. So actually, is this validated? So that's what actually how we can use it or how we can standardize that. So that is what then we have to discuss. So that is coming under the evaluation process under the research objective 5. So I have given this model with the equations to a set of people, actually using a Moodle environment, because you know that inside the Moodle environment, it is very easy to get the time that they are using. So otherwise, in my manual, if I want to take the time, it's very, very difficult. And I have used, like in my campus, since the batch size is too big, I have used 400 BSc final students, more than 60% from an aptitude test, which is regarding with Java, because my model is working with Java. So that Why I have used more than 60%? Because if a student can score more than 60%, we can think that he or she is having some kind of an aptitude level regarding the programming concept. And according to, again, from 60 to 70, 70 to 80, 80 to 90, and 90 to 100, I have again divided into 4 subcategories. So then from subcategory to subcategory also, I can identify what are the comprehension levels, and these things I have monitored. So for each scenario, I have used 30 different source codes, which is actually implemented for a real-time software. And I have asked the user by giving some scenarios to implement. I have given 30 different softwares, and I have asked the user to go through that one and to develop a new method, or identify an existing method, or modify that is coming under the maintenance. So in order to do a new method, or in order to modify an existing method, we have to use our brain. We have to have some kind of an understandability level. So then that's the place where the cognitive complexity is effective. So then I have measured how they have done it, and with the Moodle environment and with the system components, I have measured the duration. And if a user is not doing in a first shot, I gave them another shot and another shot and another shot, like until they are going to do it in a correct way. I have measured in time by time, I have measured it, and I have got the average duration. So like that, with that timing, I got that timing, and I just evaluate it like this. So you can see that if a user wants to do something only with the source code, that duration has been highlighted with a blue color. If the user has to do something with my model, with the requirement analysis, or the supporting techniques which my model is supporting, you can see the timing is little bit lesser. It means if a user is taking less time, means he can do it very quickly, means he can understand it very quickly. We are taking so much time to do something, means we are having kind of a problem with the understanding. So that's a simple logic that anyone can understand. It means with my components, with my framework, user is little bit capable of doing something with the source code. So that's what I have. You can see the dropping of the total time and the percentage of the reduction. So simply with the graphic, you can see that one. And I have done with the paired sample t-test with the SPSS. I'm not going to talk these things. I don't know whether you know these things. Anyway, from this one also, I have used a hypothetical testing, and I have verified that using my system or using my components for all the generic users, up to a certain extent, the timing can be reduced. And the visualization point also, if you can remember, I had 2 visualization components. So with the before the source code implementation and after the source code implementation. So these are the things that I have done. So you can see with the proposed component, the timing is the green color one. So comparatively with the blue color and the red color, the green color ones are like lesser. So it means still my computational framework is assisting user to understand something in a better way. Okay, so that is the t-test for this one. And with the defect tracker, also you can see with my defects tracing component, which is red color, is having a significant duration reduction. Okay, so I'm not going to explain these things, just put for your convenience. And the refactoring also, you can see the red color one is my one, and the reduction of the duration is something like that. So the paired sample t-test answer is this one with the statistical. And the evaluation of the cognitive weight, because I told you, you are the one who is going to input the values, and according to that input values, you are going to get a value for you. So this is the heat map, which is saying what are the validation points that you might have, and you can see it is more towards to the personal profile factor. So that is what I want to tell you. This from the personal profile, from the factors that you are going to be affecting with, this CW verification has been done. And I have used two, just for here, I have used only two GitLab projects. You can see the project IDs and the number of LOCs in the right hand side. So with these things, I have used 500 users. You can see the capital N value. I have used 500 users for each of these two, that is Sila Java and logs.java. These two, only for these two Java files, you can see the CW values are changing. CW values are changing means from person to person, the understandability level for each of the code. If you think about Sila.java, you can't say it's the same understandability level, because one source code, it's one source code, but 500 different people are there, users are there. So their comprehensibility is different. You can see some cognitive weight for Sila Java is most probably like 150 users have been gone with complexity level 2. It means into a certain level they can understand in a majority. But when it comes to logs.java, CW value is maximally gone for 150 people, like 5. 5 means it's lots of people are harder to understand that. Something like that. So you can see some variations are there. It's not like static. All are not same. It means from my cognitive weight, like CW value, it is capable of providing the subjectivity. And you have seen some of the, in my metric, I have defined some equations. So I have used, under the empirical validation, like theoretical validation, I have used Khanna's framework, and it validates all the 10 statements. And theoretical validation, I have used two frameworks like Wijendra properties and Bryan's framework. So I think if you have been going through with complexity metric domain, you are knowing those things. So all the properties of Wijendra properties, like Wijendra properties has 9 properties are validated with my one. Bryan's framework is having 5 properties, but my metric is capable of having only 2. But it does not say that my one is not applicable, because Wijendra properties and Bryan's framework, it is more towards to the mathematical framework. So, and Wijendra and Bryan's frameworks, that properties are like, some properties are contradictory. So if you have 9 out of 9 Wijendra properties validation, we can't expect 5 out of 5 of the Bryan's, because they are contradictory. So if 9 is going with Wijendra, definitely the properties are going with Bryan's. It's something like that. So that's why I got 2 out of 5. So this is the cognitive complexity values with the t-test values. So still you can see, and if you go with the variance, you can see variance column, you can see some positive value are there, means for one source code, different users, different values are there. That's why we are saying that we are having a variance. Variance means you have a variability. If all are getting the same value, the variance is 0. So in my case, you can see it's like 1.473 means it is a good variance. It means even though it's a quantifiable, it's a subjective value. Okay, so these are the contribution. So I didn't limit only to the personal profile. Sorry, I didn't limit into a source code factor when it comes to the comprehension effort determination. I went through the personal profile as well. And the most significant approach here is I have introduced a cognitive weight, which is subjective, and that subjectiveness is going to be verified by the user itself. And under the software development process, I have clearly introduced a software computational framework, which can reduce the cognitive complexity. And these are some of the publications that I have done through my research work. You can see those things. It's there with the VOIs as well. And the key findings, personal profile also contributes. It has to contribute, otherwise nothing with the definition. Along with the source code factor, personal profile is equally contributing. And under the personal profile, I have just introduced, or I have just used only the cognitive load under the working memory. But you can see there are so many properties that you can think of if you are willing to go with this kind of a project. And reduction of the cognitive complexity should be done, because our target is to smoothen the software development process. And the scope of the study, if you can remember, I told you the cognitive complexity is measured through the human perspective only. Because if when we process a source code, the computer point of view also, there's an understandability level. Computer is also try to understand. I didn't think about computer understanding point. In my research, I think about human factor involvement and what is the understandability level of a human. And as I told you, I always thought for whatever the user, the source code with the correct logic implementation has been given. And the sub-factors that I have taken under the main factors, which is personal profile and the source code factors, I can't say only my sub-factors are there. There are many. I can't just limit. But for my study, I have just taken only a limited number of sub-factors. And I have given more priority for the personal profile factor because that has been not discussed in the previous literature. And this is what I told you. Under that also, I have talked about the working memory with the 3 cognitive loads. And with each user, now I told you I have used 400 users for the test users, and each 400 I have divided like G1, G2, G3, G4. So under that, I have done a major assumption. With each 100, I thought they are having kind of equal comprehension levels because of the marks that they have, because of the same mark that they have obtained. But for all the scenarios, we can't take like that. But if I didn't take that one, I can't carry on the research onto this extent. So modification durations and the other reluctant durations I have omitted when it comes to the tracking the duration. So those are the things that I have done, or these are the scopes that I have done, that I have thought when it comes to the completion of my research project. So I think you got some kind of a brief idea that what I have done. So still it's not finished. I mean, my research work is finished, but I'm more towards to doing some other points with whatever the postgraduates and undergraduate students. So if you are interested, you can always contact me. So this is my official address, email address. And I'm always there to help with you with this domain. Okay, thank you very much.
Guys, we are moving towards our Q&A session as the session is over. So if you have any questions, you can just unmute and ask, or else you can just type the questions into the chat box also. Madam, there is a question that is asked during the pre-registration. So that is, what current research areas address cognitive challenges in children with deformities?
Yeah, now when it comes to these deformities of children, there are so many, I mean, when it comes to the children's aspect, or when it comes to the behaviors of the children, there are many ways that we are going to tackle the cognitive loads of the children. The way that we are pursued for whatever the task is different with the thing that the children are going to be children are going to behave. So actually, I am working with the software point of view, but when it comes to this kind of health application, or it is like that child monitoring systems, we have to monitor the behavior of the child in case if we have some kind of abnormalities. So but we want to have kind of external supervision, because the way that the children are working, or children is behaving with some kind of a task, or if the task is assigned to a children, with the children also there are so many age levels. So from age level to age level, this understandability or the comprehension effort, the tackling those things, we can't do it alone. So we have to have an external resource person who is actually kind of a having kind of a very experienced or very kind of an aptitude level of that kind of an area, And from that point of view, we have to think of that. So there are many researches which has been done for these children abnormalities and their cognitive effectiveness, but we can't say it is going to be limited only for a one aspect. That's the case, because with these abnormalities and all these applications, even if the child is a perfect one, if without any abnormalities, there are still some applications are developing which is trying to enhancing the cognitive capabilities. So like for nursery students, for the undergraduate, for like kindergarten students, like that, how to advance their mathematical level or how to advance their scientific level, like that. So in order to do that one, first of all, we have to identify how these cognitive levels are behaving for each and every age level. So for a perfect student or for a perfect child as well as abnormalities child. So these things we have to do it in a perfect way or a very critical way, because without external supervision we can't have it, because we are always going with the computational things. So we don't have that much of ideas. So that we want to have an external supervision, and along with external supervision we want to inbuild those things. So I can't specifically say what to be measured, because from each disease to each disease, or each person to or each category to each age category, the things that we are going to measure from the child point of view or the student point of view is different. That's the case.
Thank you, madam. That was clear. So, is there anyone who is willing to ask any questions? Seems like there is no any other question, madam. Thank you. And on behalf of the IEEE Women in Engineering Student Branch Affinity Group of the University of Jaffna, I would like to express our heartfelt gratitude to our esteemed speaker, Dr. Dinuka Wijendra, for sharing her insights with us. Dear Madam, your comprehensive overview of cognitive complexity in software engineering has undoubtedly enlightened us all and provided invaluable knowledge that will benefit on our academic and research pursuits. So we deeply appreciate the time, effort, and expertise you generously shared with us. Madam, please accept this virtual token of appreciation we have prepared as a small gesture of our gratitude. And I would also like to extend a warm thank you to all the participants who took the time to join us tonight, and your active participation and engagement have truly enriched our discussion and made this session a success. So, WIE, Women in Engineering Student Branch Affinity Group of University of Jaffna is now available on Facebook, LinkedIn, YouTube, and Instagram. So, where you can simply follow us and stay tuned with our upcoming events. And also, you can visit our official website for more details on future and past events. So, as we come to an end of today's session, it's perfectly okay if you're unable to switch on the cameras, but we request everyone to join us for a group photo. And it would be wonderful to capture this moment together. Thank you once again and have a wonderful evening.
Okay, thank you.
Let's wait for a few minutes. Those who wish to turn on your camera, please go ahead. Okay. Okay, seems like there's no one else, so let's capture this moment. Let's go on a count of 3. So 3, 2, 1, say cheese. All right. Thank you.
Okay then.
Okay, thanks, ma'am. Good night.
Okay, good night.
Thank you, ma'am.
Okay, welcome.